Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar, Top 5 Must-Haves for Operationalizing DevOps, brought to you by Turbonomics. We have an awesome webinar for you this morning, but before we get started, I need to go through some housekeeping items with you. First, please remember that this session is being recorded, so you'll be able to go back and watch it again if you miss any or all of it. We'll be sending an email with instructions for how to access the webinar on demand, or you can always visit us at devops.com/webinars, and it will be there for you as well. We are taking questions throughout the presentation, so use the Q&A tab on your console to submit your questions at any time. We will try to get to as many as possible at the end of the presentation, so go ahead and send those in. We will also have some polling questions for you today, so if you wouldn't mind, when you see those pop up on your screen, take a couple seconds and submit your response. We would really appreciate it. There are also some handouts you can access in the Handouts tab, so go ahead and download those for future reference. All right, so that leads me to our wonderful speakers today. We are joined by Eva Tutsai, who's product management, and engagement manager at Turbonomic, Eric Wright, a technology evangelist and director of technical marketing, and Dina Henderson, who's the junior product marketing manager. Folks, I'm going to turn my camera off and put myself on mute and let you get right into it.
All right, hello everybody again. Thank you so much for joining us today. Again, here are our photos. Here we are. We can go to the next one, Eric. So from the Digital Transformation Report by corporate leaders and PTC, these are some of the common reasons that people see benefits to digital transformation. So cloud and cloud native technologies allow for better use of automation and drives operational elasticity. Now, for speed to market, the DevOps methodologies and again, containers allow developers to build and release applications more quickly. And finally, people are really looking to deliver a great experience to their customers and are finally able to. And again, you can't achieve any of this without a DevOps mindset. Next slide, Eric. Thank you. And the way these cloud native applications are being architected today, we've got more complexity, more changes, and more stuff to manage. So these are real challenges that customers are having. Now let's take a deeper dive. Eric, can you speak to a key problem we're seeing in customer environments?
Oh yeah, definitely. Thank you, Dina. And this is having run an environment myself, I remember the days where you knew it was coming because the next quarter you'd be deploying a new application, and that's just not the way anymore. I mean, Eva, you and I, we dabble in a lot of environments, both in community work and in the customer work that we do, and that's the thing is more apps are being built inside. They're getting to production. Operations teams aren't used to the throughput at which they could do this. So that's why we had to start to work together. I came from the IT operations side. So I was always, the developers were my customer, and I had to think about things in that context. So we're seeing much more tighter integration. And in order to be successful, you have to do that. You really have to work together on moving faster. And it's not just about speed. It's speed with consistency and safety and making sure that we're not just rolling down the highway on a bicycle at 80 miles an hour. We're actually doing it in a way that we know that we have achievable consistency of outcome. And that's why we bring automation and other things into the process in order to make that happen. And when it gets to the real problem, that's not even just my own anecdotal view. This is where we talk to literally hundreds of customers and folks in the community. And it's not just about the fact that we've changed the way we do it, but now they're measured against that success. You're measured against your ability to move products into production, to cut down on error rates. So our KPIs are now tied to business outcomes, making sure that we have less tickets, making sure that performance is front and center. There's nothing worse when you put an application out And then the only performance test you get is how fast you can take calls to your help desk because there's problems. That's not the KPI that anyone wants to be measured by. So without having that visibility of performance in the way that we build, it's really hard to know that once it gets to production, that's how you're going to measure it. This is why we're, obviously kind of strongly based in the work that we do around making sure that performance and the methodologies are there from the start, from the code all the way up to production. And it's not even just me, or my team, because we've actually gone out to the industry. And, if you're a practitioner, if you're an SRE, if you're just a straight IT ops folks or developer team, the numbers sometimes seem like they're out there. Like we don't seem to measure it, but it's true, right? And we know that if you use a product, if you go to your phone and it has a little circly thing, right? And it doesn't come back, you say, you refresh and you start to think, is there another service that could do this, right? So an increase in latency means that it could either increase conversion. It also means you could lose customers. So satisfaction and delighting our customers is our goal. That's why we build these amazing applications. You're smart people. We're doing really cool things. But if we aren't seeing that we can actually empower the customer, the user, the consumer, our peers to use the stuff, and delays and performance really, really cut into that capability. Now, this is one, we're actually going to pop up a poll on this one because I love to say this like this. We're in the trust tree here. We can be honest. Our bosses aren't watching, right? So if a problem happens, can you say confidently that you know exactly what's going on? And it's okay to say no. I say no on this one because I know it's really, really hard, right? This is not something that we can do. However, you may have some potentially really mature processes and you may know exactly kind of how to measure stuff. You're using other tools and techniques. You've introduced APM and you've used some other ways in which you can measure and kind of know faster. But I would say that if we are going to be honest, or the truth of it all is, it's okay. You can't know. There's no way. It's just moves too fast. So Sharon, I know you've got a poll running on this one. I want to see if everybody's being honest here.
I know, right? It's one of those things you might not want to admit to, but yeah, we're all friends here. And it seems like a lot of folks are being brutally honest. If I'm gonna gauge that, I think I'm gonna go ahead. We got a pretty good response rate here, so I'm gonna go ahead and close that poll. Thank you so much, folks, for your input there, and then we will look at the results. Only 13% said yes. But an 87% said no. So
I appreciate it's an interesting question. It feels like it's sort of a trick question sometimes. And we use the phrase SLO. This is, I've got to give a shout out to Eva and who've really made this more of our conversation as we get more and more. So I come from the traditional sort of SLA background, right? Just like, is the system up or down? And we've really, really evolved. And SLOs are truly how we want to measure things. And this not only comes at production, but Eva, you want to talk about the real problem in the whole cycle and how this comes into play?
Yeah, I just to echo what you said, that I think the challenge around service level objectives isn't that there isn't an intent and a desire. It's a better understanding of what would be that performance metric that I could use to understand how my application is performing. Is it response time, but where can I get that response time information? So I'm sorry, Eric. So you want me to just to continue on that SLO theme?
Yeah. And map out sort of how this comes into where the problem sort of sets in the real world.
Yeah, and it's really just about picking and collecting that metric and the perspective of that metric. One of the great things about containerized applications is that you've got an opportunity to create really an agile application. You decouple it. You go from monolithic to 100 microservices, and then you go, I got to measure 100 different things now. right? And then the tooling can be slightly different, right? And then just to kind of dovetail into what you're doing right here with problem statement number 2, we've got to be able to measure this, measure it, agree upon it, right? Agree upon what the objective is, and then even operationalize that metric through the life cycle of the application. So you want to be able to collect this metric in your pre-prod environment. I'm a big advocate, I think as well as you are, Eric, of do load and performance testing before you go out to production. Try to have some concept and some way of generating load so that you can test, what you think your system's able to handle. What can each individual replica handle? If you horizontally scale, start with a minimum number of replicas, but use this SLO KPI as your driving force through that life cycle to promote from pre-prod into production. But the hardest part is really just deciding on the metric and making sure you can consistently collect it.
And we remember the meme of like the little girl with the burning house, and it just says like worked fine in dev. And this is, we bump into this all the time because it used to be a handoff. It'd be like, I don't know, understand it. It didn't seem to perform this poorly when we ran it, but not realizing that you're co-locating it with different applications and different resources and in fundamentally different designs when it goes to production. And also, once it goes to production, it's no longer one instance of the app. Like as it scales and as hopefully demand increases, right? Your applications are getting used. That's the hope. And once that happens, all of your tests that you did in that neat little laptop are basically out the window.
Absolutely. The like you said, the rate of change is staggering, right? In waterfall methodologies, we maybe had some time to predict and analyze. If you're deploying things every 2 weeks and co-locating, I have customers that have 300 applications on a single Kubernetes cluster. How do you manage that? The first thing is you really need to manage a good pipeline concept, right? Because you need to get things out there. But that same pipeline really can turn around and be leveraged for the type of automation that you need to be able to assure application performance, right?
And the thing you talk about too, and we get into life cycle, this is, I'll say even we can be like the, apps infra, right? We've talked, strongly in both sides and lived the life on both of those audiences. So life cycle is no longer just for the application either. This is now, I've done a ton of work with infrastructure automation and infrastructure as code for provisioning and ultimately continuous lifecycle management of infrastructure. So I can codify this stuff because I don't want to, if I have to spin up a new cluster, our educational services team is a great example, right? So we wanted to be able to run our Turbonomic environment for our classrooms, but we don't want to have 15 virtual classrooms just sitting there empty all the time. So I built a simple little environment in which I can spin up an EKS cluster with code. It takes about 9 minutes. And then when I'm done, just terraform destroy, it goes away, right? And so now our educational team can do that. So they can spin up the infra. And then they've got their own other scripts that then launch and actually can do auto deployments of Turbo. And then we can take the application and deploy it into it. So it's all of these different sort of life cycle things that work together. And it's amazing that in order for us to get there quickly and consistently, you have to automate. And then now it introduces, okay, great, you've done that, it's working, but now how do we measure what we call success in this? I remember like when Twitter started, I'm old enough to remember this stuff. Like Twitter used to be down for days, like hours at a time. It would just go away. You'd get the fail whale. We haven't seen the fail whale in a long time. If you saw the fail whale right now, do you think that Twitter would still be around in 3 weeks? It's way, way different because we've we've come to assume that it has to be available. And if it's not, we run to Instagram and say, Twitter down, right? That's your application now. And this is the kind of stuff that we can't have. So that's why automating infrastructure, automating application lifecycle, it's table stakes, really.
Yeah. In fact, yeah, Eric, I love your, this is good because I love your insight into the fact that we have now pipeline tools that allow us to have elastic infrastructure, right? Which is also kind of a newish thing. The fact that, my VM doesn't maybe have to be a pet anymore. Maybe I don't need to name it and coddle it and make sure it's happy. I can have ephemeral infrastructure, spin nodes up, spin nodes down, create, destroy. What's interesting, which is going to be a segue into your next point, is that with these containerized applications, I've got this application pipeline, but this application pipeline, some of the information that's coming in is an application developer setting resource specs on their applications. And those resource specs obviously have direct impact on the infrastructure and the infrastructure that's required, the compute, storage, and network. The thing is, and I love my developers out there, right? But I think that they are best suited for building functionality. And also individual application teams only think about themselves. They are thinking about their particular services and how they're performing because that's their orientation. And then all of a sudden, all of this converges, like you said earlier, Eric, at a rapid rate onto the cluster, onto the platform. 300 different application teams, each making resourcing decisions directly into their application definitions, and they get deployed onto the infrastructure. And then everybody sits back and the DevOps engineer goes, I better spin up more infrastructure just in case, right?
Yeah, quotas are what's the right quota size for your different resources is the new, how many angels can fit on the head of a pin. It's an intractable question because you don't know. You can't, we can guess. That's kind of our best shot at it, and also nobody wants to be a YAML engineer as a full-time job. This is not where developers want to spend their life in code. This is not the kind of code we want to do, right?
Right, exactly. Even though it's intrinsic, there's a relationship here, and most of the customers that I talk to, again, they continue to evolve around the cloud native journey. You start out with 1, 2, 3 poster children applications. That's manageable, right? The DevOps team and the application team can work together to kind of define safeguards and guidelines, right? But the rate of change that 3 apps quickly goes to 10 to 30 to 100, and now if organizations haven't paused and asked the question, how do we better manage the definitions of these things? How do we ask the question, is this the right amount? Then you start getting into kind of a cascading problem of, well, we'll try to do it by quotas, like you said. We'll try to use allocation models instead of utilization models. And then before you know it, you've got one of 2 things happening. You've got this great infrastructure pipeline just spinning up nodes, but maybe you don't need them. But also you are slowing down the application deployment cycle because now someone's got to do some capacity planning, some real capacity planning, because the impact of, 300 applications is a lot different, right, to be able to accommodate than 3 or 10, right?
Amen. Now, on this one, of course, Eva, this is very much in that line, right? What you've just kind of laid down the story. What are the problems that we bump into as we get to trying to move at a more rapid and consistent pace?
Yeah, and it's about like you said, it's about just having an understanding, right? If of what my real demand actually is or could be, and putting in, you know, if I have elastic infrastructure, that's good. I've created a mechanism to be able to respond. But I think that I think at the end of the day, the challenge really becomes a challenge of scale and speed. And if you don't think about the practices that you should put in place, it's only going to be natural that if you leave things to manual tasks, right, that the compound effect of the number of tenants and the scale and the rate of change, you will slow things down. That's just clearly understood. The more manual processes that you have, as the scale increases, those processes become your bottleneck. And I spoke to a little bank from north of the border, and they've adopted a platform first strategy. They said to us, we adopted containerization because we wanted to achieve these business benefits, right, of agile and faster time to market. So no app left behind, right? But in reality, they did have to introduce a process that before an application could onboard, they had to go through several steps that took several people to get involved to make the decision whether it was a go, no go. Now, I don't know about you, Eric, but I also have a little gray hair. And, there's one thing I've learned in IT over the past 30 years, that if there's a repeatable task or if there are decisions that can be made, there are points in those decisions and tasks that probably could be automated, right?
True statement. It's I call it the good kind of lazy. I'm a fundamentally lazy person. Dina can attest to this. So if I can automate something, it's my hope, because I don't want to revisit that. Especially we have people that are technically savvy. Like if I've got somebody that's generating fantastic code, the last thing I want them is to be rerunning, setting specs and definitions and eating up a hunk of their day and their week to continuously have to not just do it once, but like you said, its demand it's fluctuating, it's moving around as applications get adopted and microservices get spun out. How can is that the place that you want to be spending your effort? I can pretty sure that no one in the audience is going to be saying, sign me up, YAML engineer all the way.
Exactly. Observability tools are great, but at the end of the day, there's a human being consuming all these charts and trying to make decisions. And you're right. I think that's a developer's nightmare.
Very much. Now, and this is, to kind of talk about, and we'll actually show how this kind of plays out. And again, we want to really this is customer driven stuff. So for folks, pop in any questions as well if you're curious on how this is affecting any potential environment that you're getting. But Eva, let's move one step further and now, where have we been able to be successful in helping folks in moving from just monitor to act? Yeah.
Pipelines by their nature are intended for automation, right? So this is why we stay on the theme of the pipeline. And if we think about the must-haves for operationalizing DevOps, it's look for areas that you can automate. And we have this application pipeline that is automating deployment, but if you are collecting the right data, but also using analytics to turn data into actions, these actions should be able to now feed back into this pipeline so that there is no interruption to the flow, but also optimization can occur at the speed of software as well. So from our perspective, we have customers. So part of our analysis that we do for application teams and DevOps that helps to build trust. There's a little bit of friction too, right, Eric, between those teams that, if an application person has deployed something and the DevOps people go, okay, I'm sorry, but we've got a greedy application here. We need to, everybody, go take a look at your stuff. We need to optimize. These are important activities, but they aren't fun, and they create a little friction and tension between the two teams that work very, very closely together. So Turbonomics is an analytics platform. We turn data into action. We make current, historical, continuous analysis of supply and demand and drive actions from that. And one of the actions that is really very valuable in this relationship between DevOps and applications and keeps that pipeline moving is optimizing the size of those services. Again, we've already established it's important because 300 applications converging, each one only thinking about themselves. There's a consequence. There are risks. We want to mitigate those consequences and risks. So given the fact that the application will typically have this definition of the size of the service, and we've got a system that can monitor, analyze, and drive actionable decisions, we can merge the two, right? So the pattern that we are working with our customers is, in your pipeline, as you have these definitions, think about these definitions as parameters, not as something static, as a variable, right? And in your pipeline, expose those as parameters. And those that use Helm charts, this is already a concept, right? I can parameterize different aspects of my deployment. Make sure that container specs are part of that. Make sure container specs can be updated. We can always update live in an environment, but the pipeline also serves a function of having that record of truth, right? To be able to reference back someplace, and my deployment into production has this size, right? Or even, quite frankly, an audit trail of change, right? The pipeline provides that great capability. So use data to drive decisions that continuously optimize, like you said, Eric. Nothing stays the same, right? Things change. Your release changes. If you're very agile, you may have a new version of the service coming out every 2 weeks. That can have a different performance profile. The spec that you created for version 3 may not be relevant for version 4, right? So we have customers that start that optimization right in their primarily in their testing, their load testing environment, and then use production as a reference to say, am I really achieving that kind of demand that I thought I tested for? And drive these changes right back in through the pipeline.
To quote Charity Majors, everybody tests in production. We don't have whether you believe it or not, you're testing in production. And this is why, as we see that evolution, right? And as the application evolves, if we don't then bring that new understanding and then influence and inform the next instantiation of that application, then you're simply creating an auto-scaling nightmare where you're just constantly redeploying an application that immediately is overwhelmed, or even worse, sometimes even is underwhelmed, right? So you're basically stealing resources from other apps that genuinely need them.
Yeah, you're absolutely right. In fact, so I think what we want to do now is, from our perspective, we do have a definition too of an actionable action, right? Because it's not just that analysis will do that work of driving the right decision. It is that we don't want it to just guess that the action can be executed. If we are constrained on resources, we need that full stack understanding of understanding response time, platform resource availability, and if applicable, underlying resource that are feeding the platform. And unlike current myopic thresholds that are out there that may just pop off something or change something, and it just leaves it to chance whether that action can be executed, right? We want to assure actionable decisions, understanding that full stack. And I think that's what you're going to give us a little taste now of that, right, Eric?
Yeah. Well, this is DevOps.com, so I better put fingers on keyboards, or I'm going to scare everybody away. They're going to think this guy's just all talk. Well, let's show you what it actually looks like, and we can really bring in, where this plays out. Now, obviously, we'll show this is sort of our Turbonomic view of your environment, and when we think about the complexity, like if we just say one application needs to be defined, the first thing for all of us is making sure that, how do I first know what's going on in my environment? So it begins really with the application and making sure that I can, from the very top, be able to see, here's my application view, and I can see the aggregate and individual health and risk profile that's happening in my environment. But from the application, that health and those risks are defined by the resources that service and provide what's needed for that application to perform. If you come away from here with one thing, it's that we all had a lot of fun. And if you come away with a second thing, it's that you know what Turbonomics' goal is, right? Or just make sure that any application, we're the only system actually that can do this today, which is that every application gets the resource it needs when it needs it, continuously and automatically. And it's interesting because in order to understand how it needs to be serviced and provided, then you actually have to understand the relationships of those resources. So whether it's sitting on containerization, where we've got different applications that are comprised of the environment, whether it's sitting in Kubernetes, whether that is ultimately sitting on virtual machine infrastructure, and literally down to the hosts, out to the storage, out to the network, and out to the cloud, right? So we've got incredibly diverse infrastructure, incredibly diverse application deployment patterns. And what we're able to do is we just plug into all the management APIs of these different platforms and applications, and we gather this instrumentation continuously. And we don't need agents because you've already got some stuff, right? So say you've got application instrumentation from something like an Instana or an AppD or Dynatrace or New Relic or even just Prometheus. There's lots of folks that are doing much more, and we're very proud of the work we're doing in that open source ecosystem as well. That they can now take that application data, and then we stitch automatically the resources that are comprised to be able to provide what's needed for that application to perform, as well as make sure we do it as efficiently as possible. So it's not just, throwing resources at it. So whether you're, in a on-premises environment and you're having to look at things in the context of clusters or data centers, and then potentially have this infrastructure up view, whether you've got cloud infrastructure where you're now moving to not just a fundamentally different operational pattern, you're looking at resource groups and accounts and subscriptions. But ultimately, now you're adding in that these decisions you make have a real and true expense effect, right? So making sure that you get the right price to performance ratio. But the main thing for you is that these are your applications, so that when I look and I pick and I get a call from the help desk or from the service desk or somebody in operations, and they say, hey, we're having a problem. No one calls you and says, oh, by the way, SQL 429 seems to be running slowly. What they do is they say, Eric, there's a problem. The robot shop is down, or it's slow. What's going on? And so now that I can just immediately go to the application, whether it's instrumented by an APM platform, or you can actually custom define your apps inside Turbo just very easily, and even with automatic pulling of that resource information by tagging. So now we know, like, what is the real actual performance KPIs that are in this environment. So I can see response time, I can see transaction throughput. So I know what's going on. I know all of the resources at the different layers that ultimately are making this application up. And this is all pulled in for you automatically. You literally just pointed it at Instana, you pointed it at your hypervisor, you pointed it at your cloud API, and we do this for you. Not just the understanding of the visibility and seeing, and this is just one application that's got a variety of different services that make it up. But what it really comes down to is, what can we do about it, right? So I don't want to suddenly just say like, oh, this is great, but it's your fault. right? So making sure that I can look at an environment and be able to say, in this case, it's running on traditional virtual machine infrastructure. So I need to be able to make changes to the underlying infrastructure, like move it from one host that's constrained to another. And this could be stuff like CPU queuing and memory constraints. So not only can you see the data that derives the decision itself, but you can take the action, and even better, you can actually automate the action as well. And you can automate, Dina talked about this at the start, right? It's the idea of speed and consistency. Well, consistency comes in trust of what you're doing. So we can actually go through and we can set policies for automation levels at whether it's at the application, at the virtual machine, at the cluster, at the subscription, at the container, at the, all the different resource layers. So if you want to say, hey, this namespace, all right, let's automate within that namespace. Let's automate within that container cluster. Because when we move over to that side of the world, which is probably near and dear to a lot of the folks that are on here, well, those same resources that we had on the sort of old school infrastructure was CPU, memory, network, and storage. Well, they come in different forms. And at the application layer, they're the same thing, except we call them heap, database memory, right? So there's real application resources, and we can understand what the application needs in real time, and then do not just application layer metrics, but infra. And all of this stuff is with that goal of making sure that we can assure application performance, do it as efficiently as possible, and maintain business and IT policy compliance. So Turbo's not going to do a thing that you don't set as allowed by policy, whether that's deploying, moving machines into a cluster that's not licensed or into a region where data is not allowed to be. So if I look at just in my container cluster environment, remember when we had more control, as Eva talked about, sort of the pets and cattle, the classic sort of phrasing, right? We knew what cluster they were in. We could keep track of it. We knew what server it was on. Well, now when we move to containerization, this is the goal of this stuff, is like make elastic infrastructure. It's elastic in capability, but not elastic by nature. So if it's elastic and then you're statically assigning resource limits and different specifications, you want to make sure that, number one, maybe if you wanted to define it at the start, you'll be lucky more than you're right. And that's not your fault. That's nobody's fault. It's just the fact that we don't know how the application is going to perform once it goes out into the real world and starts to behave differently and gets adopted. And we don't know about the adjacent infrastructure. So now we're going to be able to look and say, not just what are the right limits that you need to set, what are the right specifications you need to define, but actually give you the spec so that future instantiations, we can now influence and inform the pipeline, as Eva talked about, right? So we can now help you to define that application so that the next time if we have to scale, if we have to relaunch, because the goal of this, we designed ephemeral applications. We want stateless apps so we can spin them up on demand. So making sure that we know as we get to CPU and memory, right? It comes to the four core things: CPU, memory, network, and storage. Well, you've got all these different continuously fluctuating resources that are affecting performance. And you're going to see like, oh, look at that. Over the course of time, we're looking for ideally the percentile utilization, including historical peaks and averages. Ava, you want to talk a bit more about this one? Because I know this is, again, since you built this, it's probably good that I should lean on you to talk about why this is important.
Yeah, and I want to point out something, maybe to dovetail. Ahmed asked a question about understanding over allocation, and I want to kind of build on that a little bit here too, because performance is ultimately super important, but individual components that over allocate on certain things can impact performance of other applications and services, because we should all play nice with each other, multi-tenant world. What you're showing here is exactly how we can identify before things get evicted, before things crash, we want to identify how to properly set limits, which limits can be over-provisioned, over-committed in a cluster. We have understanding of available resources on the cluster, on the cluster nodes. Actually, could you stay there for just a second before?
Oh, sorry.
Yeah. We understand quotas. But there's also, do we have that one there somewhere?
Always happens. That's what happens when you do live demos, kids.
Yeah. But maybe what I can do is I can maybe jump to another one. That there's another concept of allocation in Kubernetes, and that is the requests, which are guaranteed resources. You want to use requests in the way that it's intended, which is minimum. So we're gonna help optimize all 4 of these specifications, whether it is limits that need to be sized up for performance, so we can mitigate out of memory. We can also mitigate CPU throttling. That's another performance characteristic that we understand. But requests, we want to optimize those because requests should not be over allocated. Consider requests as minimum. Now, in terms of the concept of over allocation, there is some another perspective. Eric, you're actually well versed in this. From a ESX cluster perspective, we help someone understand their over provisioning ratios, right?
Right.
And from a Kubernetes perspective, we have a concept here that I can come to this cluster, I can plan, which is a simulation of what if I took all these actions exactly. You can go ahead and click that plan button. There you go, optimize container cluster, right? And we'll even ask you, what are some of the actions you want to simulate? Go ahead and just click run plan, because one of the things that will tell you in this plan scenario in the lower left, that
there we go. Sorry, my little sharing window is right over top of the button.
Yeah,
How this happens.
What will tell you is what's your overcommit ratio, because it's okay to overcommit. It's okay to over provision. What you need to manage is that trade-off of utilization, guaranteed requests, and that overcommit, over provision ratio, right? Because what we find is that in virtualization, people tolerate, what, Eric, on average, what do people really tolerate in ESX clusters in terms of over provisioning?
Yeah, far more than they should. It's a many to one. Like, I mean, while the documentation may say you should not overcommit more than like 1.5 to 1, it's generally about 4 to 1 at a minimum.
Which makes sense. This is virtualization, folks. This is not bare metal. I mean, you're not going to spin up one node for one pod. I mean, if you are, you should rethink your containerization strategy. So I'm an advocate for that. Limits can be overcommitted. Don't do it 1-to-1, because then you really aren't getting the full benefits of elasticity, right? So yeah, we provide those perspectives, Ahmed.
And then the good thing too is, in order to understand that this is, so Kubernetes, I get asked this question all the time, and you probably get it as well, Eva. They're like, well, wait a minute, doesn't Kubernetes just automatically scale and have that capability? Well, true, but the event that will trigger an auto scale, if you've got that configured, whether it's at the pod layer, ultimately is generally a significant failure or a massive threshold that's been hit. It's not detecting the health of the underlying infrastructure. So we could have a node that's co-located with other resources, which is what more and more patterns are appearing this way. Folks are, say, they're running OpenShift on VMware. And so they want the elasticity of OpenShift and Kubernetes, but then they also have a VMware infrastructure. So they're not going to bare metal maybe. So they run it on VMs so they could scale their OpenShift as needed, because they can just spin up more nodes as virtual machines. But when do you make the decision around when to do that? And how do you give the right view to everybody throughout that environment. Because to my developer, who I've just said, here's your namespace, this is your view of the world. And I can quite literally say, go for it, right? So I can go to my developer and I can say, this is your world. I can even give them the potential to be able to control this part of the environment and to give them sort of scoped visibility and actionability in this, their view of their overall world. But then underneath it, what we're seeing at Turbo is that we understand the host health. So we could have a situation where we've got applications that are performing poorly because of memory. So to the straight up monitoring, it will look and it will say, oh, maybe I've got a memory problem in my application. But when you go down through the dependency chain, you realize that it's a container sitting on a pod, sitting on in a namespace on a cluster that's sitting on a virtual machine. Well, that virtual machine is now sitting on a host, and that host is over provisioned, or over allocated. So it's starting to swap virtual memory, as it should, it's supposed to physical memory. And then it runs out of that, and then it's going to start to actually swap to disk. Well, all of a sudden, you realize there's a performance problem on the storage. So to every application monitoring tool out there, it says you've got a memory problem. But because Turbonomic understands all of the dependency chain and the relationship to resources, we actually will tell you, you need to move this node, a virtual machine, off to a different storage environment. And that will actually free up what looks like your memory problem. And so it's kind of amazing that when you get that total holistic view and understand how you can take action, and it's very different, right? They're much more granular changes now because we're talking about millicores and megabytes of memory changes. It's much harder for you to guess. Like in the traditional VMs and even on the cloud side, you're just picking t-shirts and we're counting binary, like computers can only speak that way. So you go from 1 to 2 to 4 to 8 gigs of memory. Well, why wouldn't you use 7.2 gigabytes of memory? I'll tell you the main reason is because most humans don't like looking at 7.2 as a number. But when it comes to containerization and defining your container spec, you've now got this freedom to work in like to the millicore layer of utilization and megabytes of memory that can fundamentally change the way it performs. And
Yep, you're absolutely right. The benefits of cloud native principles is that I've decoupled things and they create, instead of cattle, big, cats, right? But yeah. I have to herd the cats too. But I think that kind of just putting the emphasis around the top 5 must-haves for DevOps, I think that it's absolutely important that even if you are helping manage applications, right? You're helping applications onboard. I think the first must-have is that visibility. Oh, okay. Well, there you go.
I'm going to blast forward to give you context to what we're talking about, Eva. So yeah.
Yeah. And then I do want to come back to our case study, right?
Yeah.
Because I think in our case study, what I really like is that they've taken these concepts and they've automated things that they know that they can. And it's really given them the freedom and flexibility to be able to refocus efforts on more business mission critical things. But yeah, application context. We know that we all exist in IT for a business app. We don't exist just because we like to play with technology, right? So
wait, Eva, I've been lied to all this time. I thought I was just here because we were friendly and fun.
Yeah, friendly and fun in the business context, right? So application context. This also, by the way, helps in terms of prioritization. We love all of our tenants, but the reality is some are more mission critical than others, right? And it's not just to say that this node is more mission critical. It's really about have to understand that the application context, the full stack, right? And identify those points where you can automate and start to do it. We have been automating things in the underlying infrastructure, right, for more than a decade, right, Eric? The idea of moving a VM, no one thinks about that anymore, right? It's automatable. It's automated. There are things that you can automate at the container platform level, as well as even within the applications. Identify those things, automate them, and provide that feedback. Did resizing this improve response time? Yes, it did, right? It's not just did resizing this improve how much memory that I'm using. It is the benefit of that action, which is really back to the application context. Common perspective, you've already demoed that and you've talked about that, Eric, right? If you have things presented in context, but also full stack, you can have real objective conversations as well as insights, right? Then finally, SLOs. Take time to think about what is important in terms of measuring benefits to your applications. We do have customers that measure the benefits of their applications with even something as simple but powerful as number of tickets open. We worked with a bank in South America. They started automating pod placement, rescheduling, as well as sizing decisions. They got a 70% reduction in tickets. Now, that says something, right? That immediately says something. Now, one of the things that we're going to go to next is how we also validate directly with application response time. But that 70% reduction in tickets means something's working well, and it also helps give back time. So yeah, let's talk about OC Tanner. In fact, in the handouts, there's a link to this case study as well as a video. You can listen to Sam talk about this himself. But OC Tanner is a employee recognition company. They help companies develop strategies around employee recognition, as well as deliver applications that can track programs, track rewards, and also provide rewards. And who doesn't like recognition, right? They have over 13 million users. They operate in 180 countries. They're very proud that they deliver over 5 million of rewards annually, and over 1,000 multinational clients. This is a really feel good kind of business that they're in. So they've been able to deliver some great performance for their customers, 98% client retention, and they have an SLA, Eric, right?
That's right.
They have 99.9, maybe a couple of other nines. I think we started word wrapping there, percent system uptime, right?
I hope that my KPI isn't good slide font sizing, because apparently I made a bit of a boo-boo on this one. I apologize.
This is great. This is great. So now if we go into the next slide, so they decided to even eat their own dog food. Their applications are microservice-based applications, and they decided to even build their own microservice-based application that allows applications to onboard to their platform. It's called Acurus. It's actually open source. I'll put this into the chat. In fact, maybe I can even I'll put the spelling in. So they deliver innovation first platform with Kubernetes and Turbonomics. And the bottom line is they wanted to give these application people not only a great experience to onboard onto Kubernetes and reward them for cloud native, but they wanted to give them exactly that kind of feedback loop. How can I optimize this application? How can I keep it running really well, right? And that's what they do with Turbonomics. We are making right-sizing decisions for all of these different applications. They present it to their application owners, and their application owners can say, yes, I want to take this decision. And they can decide what level of automation they do, but they also will push this back through the pipeline, right? So there's the case study is in the handouts, and the case study will also lead you to the webinar that we did with him in the Apps on Cloud Summit.
Yeah, that was really cool. And it's definitely importance of what we're doing here. We're happy to share specific stories of your peers in the industry who are really doing neat stuff.
And this is our South America client, and this is again just 70% reduction in tickets. I mean, I would call that a good day, a really good day, right?
It was a good day indeed, for sure.
Yeah, and they've been able to sustain that. That's another thing about automation. We sometimes think about these things that, oh, if I fix it, then I get the benefit always. Well, but things change, right? The next version of this application quickly comes out. Performance is a journey, and automation is there to leverage. You're just not going to fix it once. You continuously fix things. You continuously optimize. And I'm happy to say that these guys are automating through their pre-production and production, and life is good.
And a good question that came up here is because somebody noticed we mentioned GKE, EKS. Even when it comes to managed Kubernetes infrastructure, well, that's fantastic that you can spin it up without having to be as concerned about how you've what's running underneath it. The downside is that you still have guesswork. You still have to choose when to actually scale it. And now, especially when you have to think about that price to performance ratio of making sure that you're giving the optimal performance to your applications for the optimal performance of those nodes, and making sure that this is the goal of better bin packing, but better bin packing with an application aware performance view is a fundamental change, so that when those applications now are coming faster, then we make sure that they have the resources they need and we get that elasticity. But it's not guesswork around when you actually do that scaling. And we can look at, as Ava mentioned, like ticket rates, MTTR, that we can decrease ultimately as a result. And we've literally seen the metrics prove out. And whatever your SLO is going to be, I know we're coming up to the hour and I want to turn it back over to Sharon. So first of all, thank you to everybody who's spent time with us today. To, of course, Dina, Ava, and all of us here, all the amazing folks at devops.com. So Sharon and Jade, who's hiding in the background, but did amazing work with us. So Sharon, I'll turn it back over to you.
Thank you so much, folks. I know we're coming to the top of the hour, so unfortunately, we're not going to be able to get into many more questions here. If you did send a question in that we weren't able to address here, never fear. We're going to wrap all those up, send them over to Ava and Eric and Dina, and they will be able to follow up with you online, or offline, rather. I'm sorry. All right. So before we finish up, I went ahead and drew the winners of our Amazon gift cards here. And those 4 winners today are Daryl J, Rodrigo P, Frank M, and Barbara H. Congratulations to all our Amazon winners. Thank you so much. We'll be sending you an email with instructions for how to claim your gift card. So keep an eye on your inbox. And if you don't see it there, make sure and check your spam folders. Again, this session has been recorded. So if you missed any or all of it, you'll be able to watch it again. We've got one last poll popping up on your screen for you. So if you wouldn't mind taking a second there and submitting your answer, we would really appreciate it. Yeah, all right. Thank you all so very much for spending your time with us today. Again, as Ava said, our hearts and our thoughts are going out to everyone affected by the flooding in Western Europe. We hope that everyone is safe and secure and that you're able to recover very quickly. Yeah, that's it for me, Sharon Florentine. We hope to see you again soon at another DevOps.com webinar. Thank you so much. Signing off.
Thanks, everybody.